All right, so now we have 8.3, part 1. We're now going to talk about geometric sequences. So in arithmetic sequences is what we talked about in both 8.2 videos. It's where we're adding to get to the next term each time. You might add a negative number, which looks like subtraction, but it's still adding. Or you add a positive number and you go from one term to the next just by adding. Geometric is different. This time they have what's called a common ratio, which means you're multiplying by the same term each time to get to the next term. So instead of adding, it's multiplying, okay? And even when it looks like dividing, that's the same thing as multiplying by a fraction. So the common ratio, we give that the letter R. So with arithmetic, we gave the difference, what we're adding each time, that was D. Common ratio, which is multiplying, is R. And in this case, it looks to me like I'm multiplying by 2 each time to get to the next one. That's a times there. Okay, so in like this example, R would be 2, because that's what I'm multiplying by. Okay, if you are given a graph to way to determine if it's geometric, it looks exponential. It doesn't just look exponential, it is exponential. Arithmetic were linear lines, or linear graphs, they were straight lines. If you're given a table, as you move up each term, you can tell to get from 1 to 2, I'm going to multiply by 2, 2 to 4, multiply by 2, and 4 to 8, multiply by 2. Okay, and then this is the formula for it. It's AN equals the first term times the common ratio to the power of n minus 1. So let's determine if each sequence is geometric. Well, I need to figure out what I'm doing to get to each term. So determining geometric, if I want from 6 to 12, I'm going to multiply by 2. Well, to get from 12 to 20, I can't multiply by 2 because that'd be 24, not 20. So I know that's not going to work because it looks to me like if I find my sequence, it's plus 6, then plus 8, then plus 10. So it looks to me like this one's more quadratic, which is not exponential. So this is not geometric because the multiplying didn't work. Okay, to get from 256 to 64, it looks to me like I could divide by 4, which is the same thing as saying multiply by 1/4. 64 times 1/4 gives me 16. 16 times 1/4 gets me 4. And 4 times 1/4 gets me 1. So that is the same all the way across, and I am multiplying, so that is geometric. Okay, looking at the graph at 3, that is an exponential graph, so it is geometric. This is a linear graph, straight, which means it's arithmetic. It is not geometric. All right, so now we want to write a rule for the nth term, so where I can find any term in my sequence. I need to write the rule, and then it wants me to find the 8th term. All right, so to write our rule, our equation was AN equals the first term times R to the n minus 1. Okay, so that means I need A1 and I need R. So A1 and R. Well, A1 right here is that first term it gives me. That's 10. R is what am I multiplying by to get to the next term? And it looks to me, I take 10 times 2 to get 20. 20 times 2 is 40. 40 times 2 is 80. So I'm multiplying by 2. So R is 2. And I'm just going to plug it into this formula. So AN is going to equal 10 times 2 to the n minus 1 power. And that's my rule. Okay, with arithmetic, we had to simplify the rule a little bit. You know that there was some distributing and collecting like terms. With geometric, it's not. You plug in A1 and R, and you're done. Okay, so it wanted us to find the rule, which is what we just did. And now it wants us to find A8, which means n is 8. So this is 8 minus 1 power. I wrote 7, but 8 minus 1 is 7. So I have 2 to the 7th power, and I'm going to take that number and I'm going to multiply it by 10, and I get 1,280. That is the 8th term in my sequence. All right, number 2, I need A1, which is 88, and I need R. So what am I multiplying 88 by to get negative 44? Well, it looks to me like I'm dividing it by 2 to get the 44, and it changed signs, so a negative half. I'm multiplying by a negative half. And negative 44 times a negative half is 22. And 22 times a negative half is 11. So R here is a negative 1/2. So writing our rule, AN is the first term times whatever R is to the n minus 1 power. Notice I am putting R in parentheses. And for reasons like this where it has that negative, it needs to be there. So here's our general rule. And now it wants me to find A8. So 88 times negative 1/2, 8 minus 1 power, so that's the 7th power. So negative 1/2 to the 7th power and multiply it by 88, and I get negative 11 over 16. Okay. Now number 3, we got our first term is 6. So there's A1. Looks to me like to get from 6 to 2, it is getting smaller, so I divide by 3, which is the same thing as multiplying by a 1/3. And I double check, 2 times 1/3 is 2/3. 2/3 times 1/3 is 2/9. So let's write our general rule. 8n equals 6 times 1/3 to the n minus 1 power. There's our rule. And then find the 8th term, A8. 6 times 1/3, and that's 8 minus 1 power, so the 7th power. So 1/3 to the 7th power, and take that number times 6, and I get 2 over 729. And then number 4. So I did fractions, now let's do decimals. Okay, this is A1. And let's see, I'm multiplying it because it goes from positive to negative, so I know I'm going to multiply by a negative. And how did I go from 1.3 to 3.9? Looks like I multiplied by a negative 3. And then negative 3.9 times negative 3 is 11.7. 11.7 times negative 3 is negative 35.1. So R is going to be my negative 3. So I'm going to plug that into my general rule. So I have A1, which is 1.3 times R to the n minus 1. There's my rule. And now I'm going to find the 8th term. 1.3 times negative 3 to the 8 minus 1 power. So that's negative 3 to the 7th power times 1.3 is a negative 2,843.1. And those are the notes for part 1 of 8.3.